How we doing? All right, everybody wash their manos. Let's take some attendance. Feeling good. Hi there, Jan. And if you have your packet, you want to get your packet out. We are going to be the inside. It looks like this. If you don't have a packet, we can talk about it. If you're at home, we're in the packet. You're on this page. You're on this page. Good. Glad to be back. I'm glad. Yeah, maybe. I don't know. Glad to have you guys back here. We are working on the packet here. And then we will do our lecture questions in our Chromebook. We don't need our Chromebook open now, but if you just want to have it out, you can have it out. So this is kind of the new schedule. We will be lecturing live Mondays and Tuesdays. Wednesday we'll practice. Thursday we'll do a lab. And the remote people don't have to come on Thursdays. And then Friday we'll have a quiz again. So the same thing is happening. We're just bringing it to you live here. And a lot of people have showed up. Thank you. I am recording this, but I can drop it into WeVideo. And so if anybody at home, if you want to talk, I will edit it right out. So no worries. You won't be seen on the screen or any of that business. Okay. So perfect. So the thing about this lecture is we usually do not start and just jump into the lecture. We oftentimes do what are called +3, +2, +1s. And that's where I would partner you guys up in groups of like 3 or 4. And we have these Petri dishes that have examples of all of these, and you would move them around and manipulate them, and you would kind of teach yourself this information. I'm not allowed to group you. I'm not allowed to give you manipulatives. So we can't do it the way that I normally do it. So this is kind of boring on a scale of 1 to what we could have been doing, but we still got to get you the content, and we're going to try to make it as interesting as possible. But so what we're doing is we are working on the Unit 2 matter notes. This is the whole thing for the whole Unit 2. So we're talking sig figs, we're talking density, we're talking matter, and your test will be at the end of next week. We do not have Friday. Next week we do not have school. This Friday we do. Next Friday we don't, so the test is going to be on Thursday. Okay, I just have to bring that up for you. Where is over here? Beautiful. So we are right here. We're on the 5th. Matter notes, matter worksheet practice. We'll find something to do with you guys here, and then the quiz on matter. And then next week, when you guys at home are back, we'll do separation of mixtures, law of conservation of mass. We'll have a review day on the 14th, but then that 15th, you will have the Unit 2 test, and it will be over everything in the Unit 2 packet. Okay? So if you have the planning type, because I am a planner, let me tell you, just so you know what's coming at you. Okay? Awesome. So that's kind of what we have coming down the line at you guys. So let's get back to this. I want you to take your pencil. I want you to put it down. And I want us just to, we're going to try to mimic a little bit of what you guys would have done in these groups, doing our little, and our +3, +2, +1s are always fun because it's, I would put you guys in groups, and the first group to get it right would get 3 bonus points, 13 out of 10. Second group would get 2 bonus points, 12 out of 10. And the third group would get 11 out of 10, and everybody else would get a 10 out of 10 because you would all get it. But we would be kind of throwing a little game on it to try to make it more fun, but this is where we are. So as you can see, I have a couple boxes up here labeled A through H. In them, what I want you to see is I want you to see like a zoomed in version of matter. A lot of people get what we're going to talk about today confused with types of matter and states of matter. Today we're talking about types of matter. I don't know if you've ever heard of pure substances and mixtures, elements, compounds, homogeneous, heterogeneous mixtures. That's what we're talking about today. And depending on what kind of physical science you've taken up until now, this might be a review for you. If you haven't taken the 9th grade physical science, this might be brand new, and that's okay. Okay, we're going to get everybody on the same page today. So the thing that makes you guys in chemistry now is that you guys have to think about it in what we call a microscopic perspective. So when I'm looking in these boxes, I'm like zoomed in so I can see atoms. Okay, we'll talk on the macro perspective, like macro big. We'll talk about macro perspective on Wednesday, but right now we're thinking if you were to zoom in. So I have here a box Can you describe what is in box A? Anybody? It's not hard. Don't be afraid. Are they yellow elephants? Thank you. They're blue circles. Is there anything in this box except for blue circles? The only thing in this box are just blue circles, correct? Is there another box in here, you can just say the letter, that has only one type of thing in it? Only one type of thing in it. What are we looking at? Beautiful. This just has red circles, right? So those are kind of similar. Everything else here has more than one thing in it. Can we all agree with that? So these two look like they go together, A and D, correct? All right, so now we're zoomed in, we're looking at things. Tell me about what's in C here. We have a red dot and a blue dot, and they're touching each other. Do you think something might be physically combined or chemically combined if it is touching each other? It's going to be chemically combined, okay? These here in the same box are just near each other. But if they are touching each other, that means that they have now made a chemical joining, okay? And this will all make sense here in a second. This is very abstract. I get it. It's abstract. You're like, I don't even know what you're talking about, man. I just see dots. I don't know. We'll get you there. Okay, stay with me. If you're looking in here, and this one's a little challenging, can you see the other box that has everything has to be touching in the exact same ratio? For instance, C has blue, red, blue and red, blue and red, and nothing in that box except for blue touching red, blue touching red, blue touching red. Is there another box? And it might not just be two things, maybe three. What else looks almost exactly like that? So it only has a very fixed ratio in it. Beautiful, very good. Do you see how these are obviously chemically combined, but every single one has the exact same ratio? Okay. Then we have these nice tough ones here. Oh, heavens to Betsy Lou. If I were to say, and I'll kind of give it away here. Okay. These are how we're going to kind of look at these. What you see here is we have two different types of things physically in the same box, and these are evenly distributed. So there's red and blue and red, but here I can see an abrupt line. All the red dots are on top of the blue dots are on the bottom. All the blue doubles are on the top and all the green triples are on the bottom. But then here it's more even, and here you can see a distinctive line, okay? So if you can think through that kind of process in your head, here are the 4 words we're going to go over today. And if you have heard of these words, you're a step ahead. But if not, we're going to get you there. Which of these sets of boxes do you think would represent an element, the most basic form of matter, the most simple? You can't break it apart anymore. It is the smallest. Very good. Okay, so your elements here are one thing. Only one type of matter. They're like hydrogen or carbon. It is the most pure form of matter, okay? Compounds are when we take 2 elements or more and we chemically join them together. And there's nothing else in that whole box. So compounds here are represented by these guys. They're chemically joined together, okay? And then mixtures are these 2 because they're in the box physically together, but they're not chemically joined together, okay? And the way we're going to break this down, homogeneous mixtures have an even distribution. Heterogeneous mixtures, you can see the pieces and parts, okay? So while that wasn't the most enthralling activity, if we had been non-pandemic, I would have given you some Petri dishes and you guys would have figured this out on your own. Okay, so trying to get your minds going without doing too much. But again, the biggest thing is that you need to see compounds are touching so that you know that they're chemically combined, and mixtures just have different things in the same box. Okay, all right, let's do it. So all the way back to matter. Pick up that pencil. Take your hand. I want you to put it on something that's made of matter. beautiful. You can put it on yourself. You can put it on the table. You can put it on your pencil. You can put it in the air because you know air is matter. Matter is everything. Everything is matter except for energy, right? So matter is anything that has mass and takes up space. Anything that has mass and takes up space. That's pretty much everything, right? Everything is made of matter. The only thing that's not made of matter is energy. It's the only different thing we got. Good. All right. So now we have two main big chunks. The first big chunk, if you want to do better at your outlining, you can put a 1 at pure substances. Okay. Pure substances break down into two types. But first, let's talk about pure substances. Pure substances have a constant composition with a fixed ratio of elements. That means it's either a pure element or it has elements joined together in a ratio that is fixed. You can't be like, oh, I have 2 hydrogens in that one and 3 hydrogens in that. It has to be a fixed ratio. The other thing about pure substances is that they cannot be separated by physical means. So once you combine two elements together chemically, you can't be like, oh, we'll just boil away that one or just filter that one out. You cannot separate them. Okay. All right. So pure substances, we have two types of pure substances. Wonderful. Let's fill them in and then we will define them. The two types of pure substances that we just talked about on the first page. The first one are elements. And the second one, so just drop down to the number 2, these are compounds. So if I ask you what are pure substances, there are 2 of them. Elements and compounds are both pure substances. Perfect. Let's talk about elements. There's a giant piece of poster in here that has a list of all of these things. Does anybody know where this thing is? Just in the, oh, very good. It's called the periodic table of the elements, right? Elements are the building blocks of everything in our universe. It's very interesting that that table of it has about 100 and some things, and actually probably only like the first 40 really count for anything. Out of all those 40 things, you rearrange them and you can make everything you see, taste, hear, smell, think about, all the stuff comes from some combination of those things. It's very, very cool. So the elements are on the periodic table of elements, and they're substances that cannot be separated into anything simpler. Okay, it is the most basic form of matter. Now we will learn later that you can have protons and neutrons, those make up elements, but once you pull an element apart, it is no longer matter. Okay, they are the building blocks of everything around you. They are the building blocks of everything around you. The trees, the air, the birds, you, the table, everything is made of some combination of the same 40 elements. And everything on the periodic table is an element. It's called the periodic table of elements. Does anybody have a favorite element? No? Come on, everyone has to have a favorite element. Can you name an element?
I like carbon.
Carbon. It's in every little living thing. Thank you, Mr. DeChant. I like platinum. It's worth something. What else? Hydrogen. Very important. The number 1 element. It made everything else. Anybody know another element? Helium. Helium's nice. Balloon. You always think of festive, fun things when you're having helium, right? There's never a gloomy day with a helium balloon. So all of these things that you're talking about, if I asked you to give me an example of an element, okay, helium, carbon, oxygen, gold, platinum, zinc, aluminum, those are all elements, okay? Purest form of matter we have. Easy. So when we're looking up here at these 2 little boxes, what I'm trying to show you here is that an element is simply all one thing. Okay, so this box, and you're going to have to be doing something kind of like this in a second. This box shows you on a microscopic level what an element would look like. Okay, if you had to zoom in, all you would see was all helium molecules or all carbon molecules. I have a couple elements up here on my board. This is Mr. DeChan's favorite, he just said. Carbon, okay? The interesting thing about carbon is that it can come in a nice piece of coal like this, but with some time and some pressure and some heat, it can also be a diamond, okay? Diamonds are made of pure carbon as well, okay? So, but nothing in here, just like this picture here, every single thing in here is a carbon atom, nothing else in there, okay? I have some copper, nothing but Cu atoms in here. This is an element. I have some zinc, nothing in here but Zn atoms. This is a pure element. And I have an iron nail here, okay? Nothing but Fe in here. Okay, so these are elements. We take these together and we make more things. Okay. All right, so we got some elements there. Beautiful. The next pure substance is called a compound. A compound is when you take two or more of these elements and you chemically join them together. Two or more elements that are chemically joined together. Okay. And the way that we represent that in our microscopic pictures is when elements are touching each other, okay? So whoop, this is supposed to be a representation of a compound. And as you can see here, they have a same ratio and they are touching. Okay, so this would actually be the representation of water. That's what this is looking like, H2O. Because you see two white ones and one gray one. Two white ones, one gray one. Can you, in that box, find anything other than two white ones with a gray one? Two white ones with a gray one? No, that is a compound. And what that would be is this right up here. This is distilled water, okay? Nothing in here except for H2Os. That's it. People are like, well, can't I just turn on tap water? Is the only thing coming out of here just H2O? What else is in tap water? What else is in tap water? Any ideas? They put minerals. There could be rust from the pipes. They put fluorine in it. They might put iodine in it. They might put chlorine in it to clean it. You might have some dirt in it. You might have, like I said, minerals if it's groundwater, things like that. So what comes out of here is not pure H2O, okay? To be honest, they actually tried to sell some distilled water as a drinking water, and people hated the taste. I mean, just hated it. Because what you are used to is water that has a little bit of salt in it, a little bit of fluorine in it, a little bit of chlorine, a little bit of minerals. So if you actually drank this, it tastes gross because it's nothing but pure water. Talk to me. We drink tap and distilled water you can buy, but you probably wouldn't find it as enjoyable and refreshing because you need those other ions in there to make it the type of thing that you're used to drinking. You like distilled? No? It has a weird taste. It's like lacking things. It's just water. Okay, so the other big thing about compounds is that when atoms join together, they lose their properties and they gain new properties. Okay, they gain new properties, just like water. Okay, water is H2O. Oxygen at room temperature. Has anybody ever seen an oxygen tank or known anybody that's needed an oxygen tank? At room temperature, is oxygen liquid? Oxygen is a gas, right? And hydrogen, if you didn't know, is also a gas. Is this a gas? This is a liquid. So once hydrogen and oxygen come together, they make a brand new thing called water, and they lose their old properties and they gain new properties, okay? Let's talk about another one. I have another compound up here. It's called salt. Does anybody know the formula for salt? Sodium chloride, NaCl, is salt. Are you worried about NaCl on your dinner table? You're like scared it's going to blow up. You're like, that's salt. That's so dangerous. You're like, hypertension maybe, but I'm not worried about it exploding. But the thing is that sodium by itself, okay, is explosive. We have some sodium metal in the building. We have to keep it way, way, way locked up because if you take it and you get it wet, which is in the air, on your skin, everywhere, it will react. What? We have it so we can show you. We'll chuck it in water later, just very safely. And then chlorine was actually known as mustard gas in some of the world wars, and it is not good, okay? It's deadly. So, there he is. But together, they're safe. So the idea, we're going to pack it real fast. So together, sodium chloride is safe and delicious. You put it on your French fries, okay? But sodium by itself is deadly. Chlorine by itself is deadly. But once it makes a compound, it is safe, okay? Same thing with sugar. I don't have sugar up here, but sugar is C6H12O6 when it's monosaccharide. This is carbon. It's a black rock. Carbon's a black rock. Hydrogen is a gas. Oxygen is a gas. Does sugar look like a bunch of gas with a black rock in it? No. Sugar itself now has new properties, and it's also delicious. Apparently, I'm just hungry, and I'm making salt and sugar as my examples here. So my compound examples today are salt and pure H2O. Okay, compounds. Good stuff. Good stuff. All right, moving on to the back. So that's all about pure substances. Elements, compounds, those are pure substances, okay? On to the next page. Mixtures. Start at the bottom with you guys. Just kidding. Mixtures are when two or more substances are mixed together but not chemically joined. They are in the same container, but they are not reacted together. Okay? They are together but not chemically joined. One of the examples that I have here is two of my compounds that I put together. I have water, I have salt. If I pour them together, I make salt water, right? But when they're together, if I were to drink this, would the salt not taste salty? Oh, it's salty. That's retained, obviously, its property. And is this no longer watery? No, this retained its property. So in a mixture, they keep their own properties. This is just salty water at this point, okay? So the substances retain their individual properties. We're starting at mixtures. We'll catch you up with the, good job. Substances retain, so again, sugar water or salt water. Sugar water is sweet water. Sugar by itself is sweet. Water by itself is water. You're putting them together. They keep their properties. Okay, when you have a mixture, everything keeps its own properties. All right, let's break it down into the two types on the next page, and then I have a little practice for you for your microscopic breakdown. Mixtures. All right. You may have heard of these terms before. I love these terms because unlike some things in chemistry, the terms tell you exactly what it is, okay? There are two types of mixtures as well. Two types of mixtures as well. The first type of mixture is called a homogeneous, H-O-M-O-G-E-N-E-O-U-S, homogeneous mixture. And like I said, it tells you what it is. So let's break it down, put a line between the homo and the geneous. The prefix in Latin for homo means the same. Same. And geneous, you probably remember from bio, is the idea is look. So what homogeneous is telling you is that is a homogeneous mixture. It's a mixture that has the same look all the way throughout. Let's talk about my salt water here. Can you see salt, individual pieces of salt in this salt water? It looks like cloudy water. It is a nice, even looking, even distribution, mixtures that look the same and have an even distribution. Okay, so my homogeneous mixtures up here are salt water if it's been mixed in. What if I make salt water though? I got some water. And I got some salt. And I just let it sit at the bottom. Can you see salt on the bottom? Yeah? But this is still salt water, but this is not a homogeneous salt water. This, I can see the salt and the water, so even though they're mixed together, we need a different word for that. This is called a heterogeneous mixture. Heterogeneous mixture. And in a heterogeneous, let's break that down. Hetero means different. And geneous means look. Okay, that's the Latin, if you read the Latin part of it. So mixtures in which you can see different pieces and parts. Okay, so for instance, I have some salad dressing up here. Can you see in this salad dressing some of the herbs and some of the oil and the water and all that kind of, can you see the different chunks and pieces in here? This is a heterogeneous mixture, okay? So again, today we're going to talk microscopically. Well, let's do the rest of mine. This is like Pepto-Bismol. It is all pink. There's a lot of gunk in here, though, when you're taking it, medicine, fluid, flavors, coloring. But can you see anything in here except for pink? Is this homogeneous or heterogeneous? Homogeneous. Very good. I have a mixture of oil and water. Can you see the different pieces and parts in there? Absolutely. So this is heterogeneous, right? And I have copper sulfate. It's all blue, so it is homogeneous. Perfect. Today, though, we're going to look at it on a microscopic view here. Remember, if it has an even distribution, then that means it's homogeneous. If you can see the big pieces and parts, and that is a, we'll say uneven, then that means that you are looking at a heterogeneous, okay? So some of these are a little challenging because you kind of got to look at it and pull back and say, what would I see at a bigger level? Okay, so we're down here. This is going to be our practice here. I'm going to give you a little bit of time to do it, and then we're going to go over it. I want you to take a look. I'll do the first couple with you. Are there mixtures that are present in the line B? So remember, what we're looking at is if it is touching, it is chemically combined. And if it is just in the same box, it's only physically combined. So is there more than one type of matter in A? They're together, so it's no mixing. These are compounds. These are compounds. But in B3, I have two different types of matter that are not chemically combined. So therefore, that one is a mixture. Okay? So there's a difference between touching and not touching, showing if you combined or not. Okay? Are there any single elements all by itself in line B? Do you see anything by itself? No pure, looking at our boxes, no pure elements here. So I want you to go through. I'm going to check in with people at home. I'm going to check in with you. We are going to go over this in about 8 minutes. I'll give you the answers. But I want you to go through, do your best, give it a try. There's not too many questions. Can you go through and can you tell me the answers to each of these questions, okay? I'm going to put the jams on quietly. Take some attendance of those at home. Beautiful. All right, let's see who's here. You work on this worksheet. We're going to go over it in about 2 minutes. I'm going to walk around my physical peeps here. Give it a best shot. I know that this stuff is tough. A lot of people don't like it, but we'll do macroscopic on Wednesday. People like macroscopic better, but this is what makes you in chemistry that you get to kind of take a look. For the quiz. All right, we gotta go. We got to go and go over some of this stuff. Let's see. All right. So we did the first two together. Does D1 contain a compound? D1, is that a compound? That is a what? That's an element. Absolutely. How about B1? Does this have a compound? Yes, they are chemically joined together in the same exact ratio, every single one. Are there any compounds present in C3? Do you see any compounds in C3? Anything that is chemically joined together? Yeah, you do. The little gray ones with the little white ones. Yes. I circled them. Are there pure substances in anything in D? Absolutely. Remember, pure substances are elements like D1, and pure substances are also compounds. Pure substances have two things, elements and compounds. So D1 and D2 are both pure substances. You look at D3 and now you have a mixture. You have dots and you have compounds together. So that is a mixture. List any boxes that only have pure elements. So the only ones that just have pure elements, and some people read that question a little differently first period and wrote any of them that had elements in that. And so I would take that as well. But the only ones that are pure elements are C1 is a pure element and D1 is a pure element. Okay. How many boxes only contain compounds? Well, I have 6 of them. Let's take a look. We can go through and we can say this is a pure element, that's a compound. This is a pure element, that is a compound. That is also a compound. Here we go. This is a compound. B2 is also a compound. I see B3 as a mixture. This also has 2 different types of matter in it, and C2 is a mixture. C3 is also a mixture. And then we said this was a compound as well. So the compounds that we see, compound, 3, 4, 5, and 6. Okay. And then we went through and we saw the other ones that are mixtures here. And the reason why is because they have 2 types of matter in the box that are not chemically joined together. Okay. 2 types of matter in the box, but are not chemically joined. And then which boxes contain both elements and compounds? Well, for instance, D3, we have an element by itself, but then we also have these compounds. So D3 is one of them, elements and compounds. Let's go back up here. And C3 also has single elements and compounds as well. Okay, I can put it up there so everyone feels good. Dots joined and dots alone. So we will practice this a little bit more tomorrow. We will also talk about physical and chemical properties and all that kind of good stuff. And then Wednesday, we'll put it all together and we'll get macroscopic, which people like more. Thank you. Sorry, I ran all the way to the bell today. Thank you guys very much. Thank you guys at home. You probably have some more to get, but I appreciate it. And we will practice this more tomorrow and Wednesday.